Welcome to the Job Shop Show, where we talk with the owners, suppliers, partners, and customers of custom manufacturers. Listen and learn the secrets of top-performing job shops, the tools, techniques, and backgrounds that have made them successful, all in the quest of raising the bar for custom manufacturing. I'm your host, Jay Jacobs. This episode is sponsored by Paperless Parts, connecting buyers and suppliers of custom manufactured parts. The Paperless platform is a secure, ITAR-compliant, cloud-based manufacturing system for suppliers that reduces the amount of time spent on sales, estimating, quoting, administration, and order processing. It offers seamless integration with the accounting and ERP software tools that shops already use, such as QuickBooks, E2, and JobBoss. Paperless Parts was founded with a mission to make manufacturing more accessible by streamlining the quote-to-cash process. Spend less time quoting and more time selling. Welcome back to another episode of the Job Shop Show. Jay Jacobs here, and today we will be talking with Damian Forsyth of Impact Manufacturing Group in California. Good to have you on the show today, Damian.
Thank you, Jay. Happy to be here.
Yeah, we were chatting a bit before the show, and one thing that struck me was your shop's 5-axis capability. Most shops don't have 5-axis equipment or the ability to program 5-axis parts. So this led into you sharing some of your background on how you got into machining and to the point where you have your own shop today and doing things that even larger shops aren't doing. So I thought we'd start there. How did you first get into machining?
Well, it's a funny story. I was sitting in my high school welding shop class, and my welding teacher came up, and he asked me if I wanted a job. I said, sure. He handed me a piece of paper, said, be at this address tomorrow at 4 p.m. What I found out was that he was part of a small group of the Chamber of Commerce, and a couple business owners had gotten together, and everyone asked if they needed any positions filled through various local businesses. And luckily enough for me, there was a machine shop that was trying to fill an entry-level spot. So he thought of me, recommended the job. I went there the next day, got hired.
So were you a senior in high school at the time?
I was, yes. It was about a month before graduation.
Okay. And so did they get to know you in the month before graduation and then just were comfortable hiring you after you graduated? How did that work out?
So it was about a 2-hour interview, and they seemed very impressed with me, and they were willing to wait until I graduated. So I accepted the job, and my first day was literally the Monday after graduation. I showed up, and they had everything ready to go.
Okay. And you had taken some welding, but machining was new. So how did they train you? How did they get you up to speed?
So I came in as I ran the saw and I deburred parts. And so it was a learn as you go. They showed me the saw. They showed me how you set the start button, stop button, all the basic safety stuff, and taught me how to read a print. So I knew how long to cut the material, showed me what different mixtures to run in the deburr tumblers. And it just kind of went from there. I was shadowed for about maybe 3 or 4 days with one of the experienced guys. And after that, they just let me go.
How large a shop was it?
It was about 12 people. It was actually an OEM that did scientific measuring devices for universities and colleges.
So this was a captive shop?
It was a captive shop, yeah.
And what year was this?
This would be 1994.
Great. Okay. And you, I understand, learned virtual Gibbs CAM software during your lunch hour? I
did. So I saw what they had 3 Fadal CNCs in there, and I think a Morris CD turning center. And I was enamored by the fact that what I thought was a giant robot was making parts, and how it would change tools, and how a little piece of material that I cut would go in there and come out all done. It was pretty cool to see.
So and that was your first exposure to CAM software?
It was. I saw in the office the shop foreman. This guy would go in there and start drawing these little shapes and flicking on things, and I got curious and I, wanted to know more about it. And they allowed me to go in there on my lunch hour and flip through all the books. And so every day I ate my lunch and taught myself how to program using Virtual Gibbs, which at the time was kind of a newer approach to CAM systems. It was kind of like a leading software at that time.
Gotcha. And did that lead to you programming parts there and advancing in that shop?
No, it did not. But and this is over the course of a while when I was there, as I was learning it, they saw how well I was doing on everything else, and they actually sponsored me into an apprenticeship program, which basically they would pay for half of like my toolbox, calipers, mics, all that stuff, and I paid for the other half as long as I worked there a certain, I think it was 6 months or something like that. It wasn't a very long time, but I thought it was a great opportunity to, get my own set of tools, and they started training me on manual lathes and manual mills.
Sure.
And it just kind of grew from there. I kept excelling, and they kept seeing it, and just kept moving up.
And how long did you stay there, and what prompted you to leave?
I believe I was there probably 18 months. And the only reason I left, I loved the guys I was working with, and they paid me good, but I was lacking the ability to understand all the code that I was writing on the Virtual Gibbs. I mean, it spits out all the G code, but I didn't know what any of it was. And so as I tried to learn more about the G code, I decided I should learn to program by hand. And I found an opportunity and people might say I regressed, but it was one of the best things I ever did, was taking another job where I'd get to set up an actual CNC mill and write all the programs by hand.
So when you say write the programs by hand, do you mean program at the machining center?
Right at the control, yes, sir.
Okay. And what type of machining centers were those?
They were Matsuras. One was an RA2 pallet changer. The other one was an MX760.
So they had their own programming code or system specifically for that machine tool.
It was on a Fanuc, I think 11M, if I remember right. But it was standard G code for most of the industry.
So you were actually programming the G code.
Yeah. So we were given prints, and you got to backfigure every inside corner radius, where's the center of it, and write all that stuff by hand. And it's a fulfilling process, to be honest with you. It's a lot of math, a lot of thinking things all the way through. Before I was exposed to the world we live in now, with RTCP and G68.2 and all that stuff. But it was a fun experience, and I learned a lot.
Yeah, that's like learning to program computers at the machine level. So,
I agree. It's very similar.
And how long were you at that company for?
I was there for over 2 years.
And what skill sets did you feel you really acquired while you were there beyond that programming?
Definitely learning feeds and speeds, for carbide, high speed, learning what actually drives the machine, how to write a program by hand. You're telling the machine to do exactly what you want. Therefore, it always saves a little bit of cycle time, whereas most today's CAM systems have post setup that are pretty safe. But they're not quite as efficient as they could be. Over time, you can always get that with the newer CAM systems, but writing a program by hand is usually, I would say, 10% quicker on cycle time, if I had to take a guess on it.
Did you ever crash a machine?
Yeah, my first day. And it's a funny story because I thought I was going to get fired because it was a half-inch carbide end mill, and this is, a smaller, it's a larger company, but the owner was very involved. And so to get a tool, you had to go ask him for it, and he would pull it out of his drawer, like, a half-inch carbide end mill. And I wrote my first program, and I dry ran it over the top, and, I felt pretty safe about it. So I put the tool in, and I jogged down to take an offset, and I didn't smack it, but I jogged down in Z a little bit too fast, and it broke a chip on one of the flutes. And so I had to go right back in and ask him for one again. And I got a look like, did you really just do that? And I didn't think much of it, but I grabbed that other end mill, went out there, part came out perfect, and we ended up being great friends working together. So it worked out well, but there's always that, those first couple of times when you're feeling somebody out. And it was a terrible mistake I made, but it happens.
School of hard knocks.
Yeah, it really is part of learning.
So what did you do next?
So as far as my next job after that, I found a job in the paper that was closer to my house. It would have saved me about 45-minute commute each way. And I showed up there claiming that I knew, virtual divs, been programming by hand for almost 2 years, put any part in front of me and I'll make it. And they called me out on it. They hired me and had me program a pretty complex job the first day. It was, you familiar with the Lumibronze material?
No.
It's an oil impregnated, it's not real difficult to cut, but to get a good surface finish on it is kind of difficult because of the little pockets of oil that are throughout it.
Okay. Is it?
So I sit down, program this part. Yeah, it is gummy, and it's very porous. And it required a 32 surface finish, which I didn't think anything of until I started cutting it. And I take it into QC, and they run the surface contraption thing on it, and they say, oh, no, that's 48. So I sat there for about 3 hours I tried honing the tip of the inserts, tried everything I could think of. And then the boss man comes by and said, how's it going? I said, great. And he said, we only quoted this to be about a 2-hour setup. And, you've been on it probably 4 hours. And I said, yeah, I'm fighting this surface finish. Everything else is great. And he says, all right, have you tried spinning it backwards on a piece of steel for a couple seconds and just barely kiss it? And I said, no, I've never thought about it. So he helps me turn the spindle on backwards. We jog it down on a piece of stainless, let it almost like rub there for a second. And sure as poop, 32 finish came out dead nuts.
So that slight tweak to the cutting tool was able to change the characteristic of the surface finish? Correct.
It has to do with the way the edge wears. I mean, I'm not an expert on it. I'm familiar with honing an insert, but back then I didn't know anything about it, and he helps me out, and job went great.
Interesting.
Yeah.
So you actually wanted a duller tool than a sharper tool, sounds like.
Correct. That's exactly what the process was.
Huh. So how long were you with this company?
I was with, the shop was called Rockland Precision Machining. I was there, I want to say 7 years. And it was the best decision I ever made. It was a group of guys and a great owner that everyone expected the best out of everyone. And I saw a lot of guys come in and make it half a day. Some guys made it a week. I mean, I always thought I was going to get fired for the first maybe 3 years I worked there because everyone was so good and no one made mistakes. I mean, obviously everyone makes mistakes, but they were far and few between. And it was just like the other companies I worked for. I started doing better and better, taking on more and more. All of a sudden the programmer had to leave for 2 weeks because his wife and him had a child. I got thrown into the programmer seat for a solid 2 weeks. And then after he came back, I stayed there another 2 weeks. So I spent almost a month programming for a couple of A55 horizontal cells and maybe 6 or 7 verticals. And it's also where I learned horizontals. I got basically I was given my own Matsura horizontal and a Haas vertical, and they labeled me the R&D department. So
Okay.
anything that was new came straight to me, and it was my job to just get it done, get it out the door.
So in terms of programming verticals versus horizontals and approaches, what are some of the differences that you've noticed and that you take into account?
The biggest differences I see is on a large cavity. A horizontal obviously is going to clear chips better when you're roughing and finishing.
Mm-hmm.
You're able to hit, at least 3 sides of the part in one shot versus on a vertical. You're forced to do it one side at a time.
Mm-hmm.
There's no differences, but there's a lot of benefits to the fourth axis. I love horizontals. They're probably my second favorite system I've ever worked on. I have a passion for it, especially most horizontals are able to hold a lot more tools, reducing setup.
Right.
Customers, they need stuff fast. And if
Mm-hmm.
you're able to have 200 tools in there that are resident, I mean, that's 90% of your programming and setup right there.
Right. So what happened at the end there?
At the end there, we got purchased by a giant conglomerate called Precision Components Group. There was a couple shops, one kind of famous called S&S. Mike Sussland owned that one. Fred Renner owned RPMI where I worked. And we all got snatched up by this big conglomerate within maybe 3 months of each other. And they closed the doors on our facility and shipped everything down to the Bay Area where they were putting everything under one roof.
Mm-hmm.
I was selected to be one of the ones to go down and help with the transfer of all the RPMI work to the new company. They took all of our machines, all of our tooling, everything down there. So it's basically everyone getting together, familiarizing with different parts, different customers, getting on the same page, how we store programs, what our setup sheets look like.
Mm-hmm.
Once we all that sorted up, things started to ramp up, and they were busy making parts.
So did you move to the Bay Area yourself, or was this temporary?
It was temporary. They offered me, I think it was $12,000 to go down there for 6 months plus a giant raise. They gave me like an extra $10 an hour. They put us up in hotel rooms, gave us $400 a week for food,
Mm-hmm.
treated us just great. It was a fun experience. So I would head down Monday morning at 3 a.m. and then blast out of there Friday at maybe noon, and I'd make it back up to my house.
And you're in the Sacramento area, correct?
Yeah. I'm just east of Sacramento. I live up in the foothills, kind of like an open ranch kind of area. Yeah.
Okay. After that ended, what did you do next?
Well, I started my first machine shop right after that. I took that money. That was a down payment on a Haas VF4. Got me into a building, got me a compressor and a CMM, and I was ready to take over the world.
Did you?
No, I didn't. Learning, being a machinist and being a machine shop owner are two vastly different things. What I've learned is anyone can buy a machine. Not everyone can make parts. A few people can get the work and the customers and get the right people to make the parts all together. So it was a learning curve. I didn't do bad, but, I didn't get rich either. I think a lot of it had to do with it just wasn't the right time in my life and my, at the time, girlfriend's life to have a shop that required, 16 hours a day, 7 days a week, whatever it took to get off the ground.
So the shop the shop was just you at that time. You were doing everything.
Yeah, and this is back in the day when a PO came across on the fax. So it was an exciting sound to hear the fax all of a sudden start printing something out. You get all excited and run back from the machine and see what order you got.
Right.
It was fun. I wouldn't trade it for the world. It was another learning experience. I did fairly well getting some work online, getting networking from previous employers. So I stayed busy, but it seemed like every job that came through the door, I needed a different thread gauge, I needed a different tap, and the actual cost of getting up to be able to be up and running was a lot larger than what I thought it would be.
Mm-hmm.
It's not as simple as a machine in a building, that's for sure.
A lot of similarities. Before I started Rapid, I had tried to start a machining business for quick turn plastic parts. I called it Plasticam, and it also didn't work out. My wife, just before the machining center was to be delivered, found out that she was pregnant with our first child, and the plan had been for me to go into that business, make it work, and then eventually we would start the family. And in the meantime, she would have the health insurance and an income to support us, and that basically went out the window. So
yeah, life has its way of checks and balances. That's for sure. You can't foresee everything, and then so I was kind of in the same boat where the home life wasn't exact for the right time and the right business, and I think that put a lot of stress into our lives.
Mm-hmm.
And so I ended up closing the shop. Luckily, I was able to sell it. Basically, they bought the machine as long as I would go with them to another shop that was kind of an upstart, maybe another 60-minute drive from my current location. So we uprooted everything, put it all in their building. I went over there, and things were okay. They definitely had a different philosophy on how a shop should run.
Mm-hmm.
So there was a lot of differences between how I foresaw things and then how they wanted them done. And a lot of that wasn't spoken up front. And so I think that was a big mistake on my part, is not asking enough questions like, how is this really going to work? What do you expect out of me? Learning more about them on how they want to do things and where they saw themselves in the future. They were very conservative. They quoted things really high. They weren't awarded a lot of jobs, but they didn't want those. They only wanted the big winners. And everything was really like calculated down to the penny. Whereas I was more of a, you need that part in 2 days? All right, I can do it for $500. I order some material and there's a part. And they had a different approach on how things should work. So that didn't work out. And I reached out to one of my old bosses, and he was running another machine shop pretty close to where I live. And I went there, took over the horizontal cell. It was two Hitachi CDs with, I think.
So back to the horizontals, huh?
Yeah, back to the horizontals, where I always seem to gravitate to. And that might just be a mindset thing, like you discussed earlier. Mm-hmm. But as long as you're able to visualize the whole process, how many parts can I put on a rail fixture? What's the best way to maximize lights out machining, reduce cost? What kind of tool can I use to make this part 10% faster? Those are the things that always drove me, always pushed me, sometimes kept me up at night. So maybe it's just the way I'm wired. I don't know. But
well, let me stop you here for a second, Damien.
Yeah.
So you are obviously a self-starter, and I know with your current shop you have a lot of advanced technology. How do you learn? How do you find out about the newest advances? Is it blogs you subscribe to? Do you read magazines? Do you go to shows? What's your process for acquiring knowledge?
My biggest one is the individual local reps for the tool salesman. They want to sell you something, and I always say I have an open door policy. If you got something that's better than what I have right now, and they always do, the guaranteed trial offer. They're like, swap this out for that. Run it at this. And if it works, then, everyone wins. I'm buying their tools. My parts are faster.
And is that beyond tooling? Is that the same thing for machining centers, the fixturing, measurement equipment, all those sorts of
I think those are all broken into different categories. More of the high tech stuff, I find a lot of it on forums. Maybe I used to be real big on the Mastercam when I
Yep.
learned that, and learning from other people. People always have problems. People always have solutions, and listening to others and learning from others has always pushed me in the right direction.
So how do you set yourself up for those conversations?
Usually it's as simple as just asking. Never be afraid to ask. I think that's one of my best traits is
Mm-hmm.
I don't know everything. I want to learn everything, but I know that's not possible. So what I try and do is just be better. Every day my goal is just be better. Don't be great. Don't hit a home run. Just be better. And that kind of keeps pushing me to maybe do a little bit of research on a new cutter or maybe a new fixture. Or maybe I saw something on the internet that said, wow, I never thought about holding a part that way. That's a great idea. And I'm always willing to try it.
Do you have a group of people in the machining industry locally who you get together informally once in a while, have a beer, or really interested in how the transfer of knowledge is occurring at the job shop level?
Yeah, so a great example of that is the local machine tool reseller out here is Selway.
Mm-hmm.
And they host I think it's called a Wednesday night, meet and greet. And it's all guys, shop owners, shop foremen, people that, are just setup guys, people that want to be a setup guy. It's a whole group of people. They provide pizza and a bucket of beer. Everyone gets together and everyone starts chatting. Now, the one thing I've noticed is people don't like to give away trade secrets. And when you look
Sure.
at it like it's a secret, it makes it seem like it's, taboo. But I've always been of the mindset that if shops worked together instead of against each other, everyone would be better off. I'm sure a lot of people would disagree on that, but it's my personal opinion that from the people I've asked and they've shared things with me and I share them with other people. And if everyone's doing better, then everyone wins. So those groups where you get the people that are actually making the parts together, that's usually like the brain cloud aspect of it where people start throwing out ideas. It's a great way to learn and network and meet and talk.
Well, I like the fact that you said that it's not just the owners, it's the machinists and setup people, and sounds like people who are wanting to upgrade their skills that may
That's
not
correct.
be. So the fact that they make that open and there's the mingling of the different skill levels is a great service that they're providing.
Yeah, it is. And it's not catered to just the owners who might buy a machine. It's more set up for everyone that wants to be a part of it. And the honest truth is, yeah, there's machine shops and there's owners, but without the guys on the floor, there is no machine shop and there is no owner.
Correct. So how did you get into the Mastercam software? Were you still using the Gibbs at the horizontal shop?
No, they actually had Mastercam there. I'd never used it. And basically my job was just to make sure that parts got set up on the cells and ran lights out. But again, when I ate my lunch, I would trot on up to the programming room, which was upstairs. And on my lunch hour, I taught myself Mastercam. And next thing you know, we had a couple parts on the horizontal that were struggling. I threw out some suggestions, and the shop foreman said, well, I trust you. Why don't you reprogram it? I reprogrammed it, cut the cycle time by 42%, and it was a very profitable job for you. And I redesigned the fixtures. They were running them on a single fixture in the center of a pallet so they could just hit all the sides. But there was only two sides that need to be hit. So I made a fixture that kind of held them in a semicircle, like a half moon. And so then we could load 8 of them on there at a time. And that got us another 4 hours of free runtime at night. The owner caught wind of that. Next thing you know, I was programming almost everything that went to that cell.
That's a great story.
Yeah.
And from there, you went to Kratos Defense?
I did. So at that point, I thought I was a fancy Mastercam programmer, and I saw an ad on Craigslist, And at this time, this decision was driven. I really wanted to buy a house. I think I was 25, 26 at the time. No, I was probably 28. Yeah. And, it was time to, get a house and be, a grown up, so to speak.
Mm-hmm.
And this job offered, from what I read on it, just a lot of stability, a better 401, better benefits. And I really liked what they were doing. It was state of the art. It was a drone manufacturer. They built military drones for targets, and now they're even doing unmanned, warfare systems. And it just really intrigued me. Like, I've been making these parts that are pretty much prismatic for most of my life, but
right.
What's all this surfacing and waving, and how is that even possible? So I applied for it, and it's funny. They liked me, and they said, well, we'll think about it. They brought me back in for a second interview, which I've never had. I've never not gotten a job on the first interview, so I didn't think I got the job. And when they called me back, they brought me in with more of the high-level management people, and we were sitting around, and we talked for a good 45 minutes. And at the end of it, they said, well, do you have anything you'd like to add? And excuse my language, but I said, I like to make cool shit. And they said, well, we like to make cool shit around here too. You're hired. And that's how that one went. And the story of my life, swim or tread water till you can swim. I got thrown these crazy lamination tools. I've never seen a build that was 1,200 pounds before. So it's a lot of pressure to not make a mistake.
Yeah.
And, luckily, the programmers I was working with were awesome. Showed me all these little secrets. Because I knew the basics of Mastercam, but I didn't know all the powerful stuff that you could do with it. And ended up working with a great bunch of guys. And it was a real fun experience.
So is that where you learned to program with 5-axis?
It was. And we actually had a little bit of difficulty with our 5-axis programming using Mastercam. I think it was Mastercam X during the time. And I had made my way up to the programming supervisor. So I was programming maybe half the day and then, more management stuff the other half. And I reached out to a friend about a question in Mastercam, and I hadn't talked to him for about a year or two. He replied back with, man, I can't help you. I'm using Siemens NX now. And I said, well, what's that? So I did a little bit of research, and I was pretty blown away at how simple it was and how powerful it was at the same time. So I proposed to my boss that if we were to change cam systems, we could cut down our programming times by a good 20%, also reduce some cycle times, and more importantly, eliminate errors. So after about 3 months, we did an ROI on it. We got an eval license. I learned it by myself, and as I usually do. And then we had a little, head-to-head competition. Boss man brought out the same part to both of us. He programmed it in Mastercam. I programmed it in X. It took him about 4 hours. It took me just over 3. My setup sheets they felt were superior. Theirs were lacking. And then the cycle time was about 15% less on the NX side. And it really changed their future, going forward with, look, we're able to do this, this, and this, and now we still have time to do that.
What drove the reduction in cycle time, the difference?
The ability the best way to put it is not waste any time cutting air. NX is so model driven, where at the time Mastercam, you can throw a model in there and you can use it, but the NX side of it, it always knows where your tool is, where it can wrap it to, how it can get around a part. Whereas in Mastercam, there's a lot of manual entry of clearance planes. Let me wrap it up to this. And then I want it to wrap it down to that. NX handles all that automatically. So that was almost a freebie of reducing the cycle times just in that aspect.
And what year was this when you did the head-to-head?
I'm going to say 2010, roughly that era, 2012 maybe.
And you've been an NX guy since then.
Yes, sir. NX knows the depth of the modeled hole. There's no entry for that. It saves a lot of steps. And then we also use, G-code simulation. That was a big plus for us. Being able to actually simulate the G-code and not the NCI file.
So that's right in the NX program?
It is, yeah. It's an extra license, but it is integrated. So I don't have to pull all these things out into another system to try and simulate them that way. I have used Vericut, and I love it. I think Vericut's the best package out there. But for us, when you're doing one-offs, the NX never failed us on our simulations. It showed us exactly what the machine was going to do.
Well, the integration and not having to take extra steps is a huge plus. So,
agreed.
What got you to say, I want to go out and start Impact Manufacturing Group?
There was really nothing. It was just, I just had a feeling of, maybe it's time for a change. I kind of had some regrets on how my first shop ended. I felt I could have done a better job.
Mm-hmm.
I felt I had learned and grown as a person, as a machinist. I was at a very great spot in life. I met a girl and we just got married. Life was great. And kind of your situation, like you mentioned, my wife had a very good job, had the benefits, had everything that, I could go take a loss for a couple of years and try this thing the right way instead of trying to make it, in 90 days. Let's
Right.
give it 2 years.
Right.
And I think that's a big difference.
Yes. So you started Impact Manufacturing in 2013?
2013, yes, sir.
And at first that was a part-time gig?
It was a part-time thing. And, we got the machine, we got the building. We didn't have any work, but I knew a lot of people. I made some phone calls, and some other shops were offloading, the one-off stuff that a big shop doesn't always want to deal with.
Mm-hmm.
And that's my background is R&D one-off. I love it. There's nothing better than taking, you get a model and a print, and you make a part in a day, and you only got one shot at it, and it comes out right. I mean, it's a very rewarding feeling. And it's also fun. It breaks up the day. I remember the days of the horizontals and lots of being an operator and inspecting parts all day.
Mm-hmm.
And that was a great experience, but I really seem to gravitate towards the one-offs.
So when you started Impact Manufacturing, did you have any core ideas or philosophies on how you wanted the shop to run? It sounds like the one-offs are what you gravitate to, but is there anything else that you had in the back of your mind, whether you formally or informally said, this is what we're going to do?
Yeah, so I put a lot of thought into opening this shop. I took every lesson learned from everything I'd ever done, everything anyone had ever told me. And I just sat down one night and started writing almost like a procedure. What would a day-to-day life look like in part flow? So obviously we got to cut the material. We have to, inspect the material. We got to program it. We got to machine it, inspect it again, get it plated, inspect it again, ship to the customer. And I started thinking, what are the things I've learned in my life that reduces the time? And the number one thing I've ever done to reduce time is modular fixturing. So we did some research on a company called Lang Technovision. I believe they're a German company. They have a system that is just flawless when it comes to sharing in between machines, inspection. The part never has to come undone. It's always restrained onto your fixture. It can go onto a lathe. It can go anywhere you want. And that's what we wanted to be. We want to be vertically integrated to where a part could travel either path and not lose time. We didn't want to spend time building fixtures. We wanted to make parts, and we wanted to make them fast. And that was one of the biggest and best decisions I ever made, was going with a modular system for the whole shop.
So if I understand this correctly, because we did not use a modular system at Rapid, you put your stock in a Lang fixture, and
Correct.
you will put it in the mill. Say that is a where you're clamping it into initially is a subset of a system. So you're pulling it in and out, and there's easy locating features and locking mechanisms.
Exactly. Sorry, I spoke that like everyone knows what it is. Let me go a little bit back.
Sure.
So the Lang system, it's modular as far as there's 6 to 7 different size vices, and I think their biggest vice is only 6 inches wide. They're super low profile. They all have mounting studs on the bottom. When you think of like pull studs on the back of a Cat 40 tool holder,
Mm-hmm.
those drop into precision bores, and then there's a hydraulic screw that you turn, and a cam leverages and locks them in. So to change a part or a vise, it probably takes about 15 seconds. But the benefit is all of our machines have that pattern of subplate on the 4th or on the table or like on our 5th.
Right.
That's all covered with those. And what's great is they're a known spacing apart. So let's say you have a part that's 20 inches long, you know exactly where the vise will go on the left and the right because they're going to be mounted into those bores. You know your span in between them. When it comes into the software, we have all that pre-modeled up. So we don't waste any time creating fixtures or layups or how this might work. We know how we're going to hold it just as soon as we see it.
And you started that from day one.
I did, and it was expensive. And the honest truth is we didn't have a lot of money, and I bought a lot of stuff on eBay. I would check Craigslist. Once I saw the value in it, I just knew we had to have it, and I did everything I could to get it.
Yeah, I was going to ask you what your investment was, because I can imagine that is a pretty expensive system. Not that it's not worth it, but particularly for a startup shop, it's an investment.
It is. I would say if we had to guess, we probably have 75 to 85 grand in Lang fixture work holding devices in the shop.
But it saves time and improves accuracy. So
yeah, when you look at the ROI on it, it's a no-brainer because we can run a part on our 5-axis, unbuckle it. We have a Lang plate on our CMM. It can check the whole part. If we find one discrepancy, undo it. It goes right back in where it was within a tenth or two. You know, we can make an adjustment. Maybe it was a cutter comp. Maybe it was a tool length. Mm-hmm. And we're back in business. And we don't have to make that second part. Making the second part when they only need one doubles your cost.
Yes.
So if you look at it that way, if I can just make sure that first part is right, I'm saving the customer money every time, which is making them happy. They give me more work. I make more money. It's better for everybody.
Win all the way around.
That's right.
On their website, I checked out Lang before our conversation, and they call this 0-point clamping. What do they mean by 0 point?
I think that's just a term they throw out, but it might have to do with the tolerance of how they locate. It's amazing how they locate it so accurately. And they have a whole system to where, let's say we put on one of our VF4s has 8 of the plates on it. They actually have a gauge that they'll loan you for a week that is precision ground to make sure all those plates are exactly spaced when you tighten them down. It's fascinating how much thought they put into it. And I've noticed that there's other companies coming out with very similar stuff, and I'm sure it's great too. But Lang has treated us right from day one. And I usually stick with something until it does me wrong. So right now we're Team Lang, that's for sure.
Gotcha. You offer 5-axis machining.
We do.
And that's unusual for a one-off shop or a shop that does prototypes and or quick turn. When do you go to a 5-axis versus your 3-axis or 4-axis? What's the driver there?
The honest truth is our philosophy is probably different than most. It is cheaper, better, faster for us to do a simple part on a 5-axis mill and have a 3-axis only dedicated to taking the backside, whatever we were using to hold the part with.
Mm-hmm.
That's all our verticals do is take off the backside and deburr. We run everything on the 5. The reason we're able to do that is because we have a vertically integrated system, from the programming to the fixtures to the solid models to the G-code simulation to our resident tools that we leave in there to do, and that's all depending on customer. But our customer base, we have a good set of tools that covers 80% of their parts.
I'm thinking back at Rapid, and we had some trunnion tables, which I called the poor man's 5-axis.
They are. I ran those too. Yeah, I'm familiar.
Yeah. But I would always be pushing back against my salespeople because they would want to go out and say, "Oh, we offer 5-axis machining," and I would say, "No, we do 3-axis machining with trunnion tables, and we just don't take the part off as often, which gives you better tolerances." And that was always a yin and yang with the sales team there. So I definitely understand your philosophy of machining as many surfaces as possible at once without having to refixture. Makes a lot of sense.
Yeah, it's simple that, the less times you touch a part, the cheaper it is going to be to make. And I have to stress that the way technology has evolved, it is no more difficult to program a 5-axis than it is a 3-axis.
And why is that?
It's the way the software has come to life. It's the way the machine tools with dynamic work fixture offsets, to where back when you ran those trunnion things, you probably had to know center line of rotation. And you probably had to program that part out in space. And then it would run around and twist and do its cool things. And then you'd wonder why a hole's a little bit off. And you'd find out that maybe that number from center line, instead of 6.0022, was 6.0012. There's a lot of chasing your tail on those older systems. Most of the machine tools these days, the probe comes down, you set your work offset wherever you want it to be, just like on a vertical 3-axis, and the control takes care of everything from there. It's no different. It is easier to program. I shouldn't say easier, but I consider it the same to program a 3-axis versus 5-axis. I don't see them as one being any more difficult than the other. And that goes as far as the way we have our NX set up. When we open a part, it asks us what template do we want to put it in. So if we pick, let's say a 5-axis machining center, it knows to load those tools into the software. It knows that this fixture plate and the machine tool itself is going to come in for the simulation. There's no wasted time trying to go and find something. The last thing we do is pick out which lane fixture we're going to hold it with and use a little assembly mate constraint to plop it where we want it to be, and we're off and programming.
And are you still running the G-code simulation on all the parts?
We do, on every part.
Do you see conflicts, gotchas occasionally, or how?
We do. Mostly it could be as simple as, like, I could save a lot of time. Once you watch it run all the way through and you see how the machine's going to actually rotate and spin from here to here, as opposed to watching a simulation that does not use G-code, you just see the tool do some cuts, and you see it rotate to the side and do some cuts. It doesn't give you that visualization of, if I reorder those operations right there, then it's only going to have to rotate twice. So I should, little things like that. Of course, there's always clearance issues, especially, long lease, neck down something. And we set our stuff up to clear at 30 thou, which is pretty safe, because if it clears by 1 thou, then you're good. But that's also a testament to our lane stuff. Everything is within a couple tenths on the size of the vise, the width of it, how thick the fixture is. So it pre-populates our G10s inside the cam system. So when it hits the floor, the setup guy, he knows where it's going to go. He just has to watch the probe run.
Makes sense.
Yeah, and also to get back onto how we make these things go so smooth, is we spend a lot of time up front. Our setup sheets are so detailed. They call out the specific holder, the tool by part number, how long it's sticking out, the projection, the diameter has to be relieved, so length to cut. All that stuff is on these nice, beautiful PDFs, along with every tool cutting every surface is all on our iPad. So the guy out there flips through the iPad and he's watching it change and be machined as he's scrolling through the photos of every operation.
So the software on the iPad, is that something you created, or is that off the shelf?
It's a plugin for NX. It's called NCmatic. I believe it's a guy out of Switzerland. He does an amazing job extracting information out of NX to make a user-friendly setup sheet. It tells you everything you could ever need to know to make that job.
So when you make a new hire and you bring someone into the shop, is it difficult? Sort of a two-part question. Is it difficult getting them up to speed on your systems? And the other part, which I always found challenging in the shops, was having someone be consistent with the systems, even if they did understand them.
Yeah, so the most challenging part is having people be consistent. I always like to call it the Patriot way, the Bill Belichick philosophy. We do it as a team, or you're the next man out. And it's not that we're trying to, not give someone a job, but it's very important for everyone to be on the same team, and we all have to work together. Because if one person doesn't do their job, that part could be a scrap part.
Right.
And it's that simple. That's our philosophy. It's worked for us so far. We actually hired a guy last year that was a logger. He'd never seen a machine. He was
a logger?
Yeah, cutting logs out in the woods. Yeah.
So a little bit different tolerance there.
Yeah, a little bit different tolerance. And he's one of our best 5-axis guys.
Huh.
It's you never know what you're going to get, what comes through that door, but we just have an open mind, and if you're willing to buy into our proven system, you're going to succeed.
I like how you've systemized it. It makes a lot of sense, and you're really taking advantage of the technologies that are out there today.
Yeah, and that even goes as far as we do on-machine probing to, check some critical bores. That's not our final inspection. Obviously, everything goes to a CMM, but it's so easy to have that machine come down and tell you the distance from that surface to that surface. And so why not take advantage of the technology that's there?
And when you're doing the probing at the machine, and it's been a little while since I've been able to observe this, are you getting an alarm if you are out of a certain range, or does it stop and the operator needs to confirm a measurement before proceeding? How does that work?
Correct. So what we do, our one weakness is we're not able to program our probes to do inspection with our current CAM system. There's guys that know how to do it. I'm not that technically savvy on it. So we do everything with a set of macros and a small program that we set up to check a certain amount of bores or features. And the guys on the floor, they know exactly where to put in the information they need to. And what it'll do is it'll come and check something. And if it's greater than, and this is all just basic macro. And basically it'll just stop and tell them, read this dimension. So they'll go to setting whatever it is, 210 I think we use 210 through 220. They will write down those on our, let me back up. We make a pre-inspection checklist. So everything that's critical that needs to be measured on the part is on a sheet that's printed with the setup sheet that's bubbled with the print as it all goes to the floor. Now, how we streamline that in the office is, let's say one end mill cuts 7 features. Well, we know we only need to check one depth and one diameter, because if those two are good, everything else will be good because they're tied to each other.
Right.
So a print that might have 100 dimensions, our in-process inspection sheet might have 12. But if those 12 are good and we did our stuff on the CAM system, then we know we have a good part. So that brings us back to the probing. So on that list, it'll have the certain dimensions that they need to verify on the machine. And they're all skilled enough to be able to edit the codes and tweak them, have it go over and probe a bore, probe a surface, maybe try and do a true position, all that simple stuff. And they just record it in the little Excel spreadsheet that's printed out, and then we're good to go.
Making parts.
Making parts.
So everything we've talked about up to this point has been making parts. How much of your day do you spend quoting or estimating?
I would say on an average day, I probably spend 2 hours quoting.
And
a lot of that has dropped. I was probably up around that maybe 3 to 4 hours a day. But we found a company called Paperless Parts. We got a call from them back in December, and I had the first conversation with them, and the mindset and the vision on where they are and where they want to be. I've never signed up for anything like that before in my life, but I trusted them, and it was one of the best decisions I've made. At the time, we experienced a little bit of a slowdown. We were looking for a way to market ourselves a little bit better, what separates us from another shop. And this seems like a great tool. If I could save time on my quoting and deliver, the buyer a higher end quote, it just seemed win-win. So we signed up with them, and it has been phenomenal.
how has it reduced the quoting time?
The number one aspect is we bring in a part. We don't have to open it in our CAM system, so we know the exact stock size. We can see all the features that need to be machined. It'll tell us how many potential setups we would have if we ran it vertical. But if we're running it, on a multi-axis machine, then we know we can adjust that from there.
Right.
It calculates the cycle time. And one of the biggest things, I always did this in an Excel spreadsheet. I would have to manually enter, okay, I think it'll take 60 minutes to program. I think it's going to be a 1 hour setup, runtime 45 minutes, and just go through those. And over time, you realize that all of our quotes all seem to come out about the same price. So instead of it being my opinion, it's actually going off facts of, a volume of material being removed and how fast can that be removed in a certain, time frame. And it's a fascinating system, and we absolutely love it. It knows the cost. We enter all the cost of our out process. Let's say it's plating, grinding, lapping, hone. Those are all pre-populated. So all we have to do is check a box, and it's added into our quote. And we never miss stuff because it's so, I think when it comes in, it asks us 3 questions. I think what machining center we're going to run it on, the material of the part, outside process, and then quantity. So 4 questions. And after 4 questions, 90% of the quote is done. And that's the time when you start looking through it. You look at the part, you look at the price, analyze the print. Oh, yeah, I got to add in, hard anno. So let me put that in. Those 2 holes need mask. Check that box. You're ready to submit to the customer. It's that fast.
So you're getting quotes to the customer faster?
Yeah, we get quotes. The honest truth is we try and get a quote back in under an hour after we receive it.
Under an hour? Wow. Have you noticed the faster that you get a quote back, the more likely you are to win the order?
Yeah, it's phenomenal. Those things go hand in hand. And I did some thinking on it, and I thought about it this way. What if I was a buyer and someone said, hey, I need to get these parts done. Here's your action item. I'm going to ask you tomorrow, where those parts when we meet at 10 o'clock. If the buyer gets them sourced, his job is done. So he's a happy person.
Sure. He can say in the meeting, I've got them on order. They'll be delivered on this date. Yeah.
And then people are like, well, how'd you do that fast? And, a lot of it is our capabilities and how fast we get things done. A lot of it is our software. A lot of it's our technology. And a lot of it is our quoting system.
There's a feature where you can offer expedites in the paperless platform. Is that something you take advantage of?
It is. And I would say 25% of the time, a buyer will choose the expedite. And so that's better revenue for us. And they're willing to pay that expedite. You're not it's not a shakedown. Everything's up front. Like they get to pick when they want their parts, and they get to pay what they want to get their parts. It's just a very straightforward upfront system.
Did you offer or charge expedites before the paperless platform?
We'd never even thought about it, to be honest with you. So it's been a good revenue gainer for us, that's for sure.
And a good service for the customer because they understand that they can get the parts faster, and it's a business decision for them to say, do I want to pay this much more money for the faster delivery or not?
Yeah, it's no different than Amazon. Let's say, it's someone's birthday and you forgot their birthday, and you hop on Amazon to buy something and you can have it tomorrow for that extra $4. That's a choice you make.
Right. Your choice.
Yeah, and that's the way it should be.
So we've covered a lot of ground here, Damien, and you have such a passion for the manufacturing. Where do you put your passion in your personal life? What do you like to do for fun?
I enjoy fly fishing. I was a fly fishing guide part-time throughout my life. I enjoy archery hunting. And I have a 2-year-old and a 4-year-old, and that takes a lot of my time and passion, and I wouldn't trade it for the world. And to tell you the truth is, being a business owner is very demanding, but having that opportunity to have a semi-flexible work life and spend time with your kids and not miss a game and go camping on a weekday instead of a weekend, I wouldn't change that for the world.
I know you're working hard, but it's important to have that balance and take the time. So I'm glad to hear you're doing that.
Yes, sir.
Is there anything else you'd like to share with our audience today?
Not that I can think of. This is my first time doing anything like this, but I appreciate the opportunity, and I was thankful to come on and be a part of it.
Absolutely. Well, where can customers get more information about Impact Manufacturing Group?
The easiest way is online at www.img-mfg.com. It's got everything on there. Our website has a plug-in. A customer can just drop a part on there, and they get a quote back in about an hour. So anyone out there listening, looking for a new quote, even if you're just comparing a quote to another price, we're more than happy to quote it because our quoting system's pretty dialed in right now, so it's not a big deal for us. We don't mind it.
That's fantastic. Well, Damien, I'm really glad we had you on today. I appreciate you sharing the details of your journey, and I really love your entrepreneurial spirit. I'm inspired by your desire to constantly learn, and technology is so positively changing custom manufacturing. Some of the ways that you're applying the modular tooling I was not familiar with. So if that can help another shop reduce their cycle times, improve their quality, I think that we've got a win under our belt today. And certainly your customers are winning every day when they're working with you.
Yeah. That's, we wouldn't be here without our customers. So we thank them every day. And anything we can do to help them out is a working relationship that we enjoy.
Yeah. Well, again, thank you very much, Damien. This wraps another episode of the Job Shop Show. Thanks for listening. Keep those spindles turning.
All right. Thank you, Jay.